Good morning, everyone. How are you today? Okay, I hope all of you feeling good. So today we are going to learn about set, relation, and function. And after this class, I hope you will be able to understand and explain about the concept and application of set with this example. The second, you will be able to explain the concept and application of relation with examples. And the last is you will be able to explain the concept and the application of relation with example. So first, we are going to learn about set. So have any of you know the meaning of set? Okay, so set is defined as a well-defined collection of objects. So, what is well-defined? In other words, well-defined means that there is a clear objective criterion for determining whether an object is belong to collection or not. To put it simply, we can always say with certainty whether something is a member of a set or not without relying to personal opinion or subjective judgment. Okay, so the individual objects that make up a set are called elements or the members of the set. So, okay, on the screen there is two sets. The first set is a set of the girls in the class, and the second set is a set of beautiful girls in the class. So, can you tell me which one is a set? Okay, so correct. The left one is the set. So, why is the left one is the set? So, the left one is a set of the girl in this class. A is the set containing Anna, Elsa, Rapunzel, and Cinderella. So this is a valid set because the criterion is objective. No matter who you ask, whether it's Christoph, Hans, Olaf, or anyone else, the answer will be the same, since the definition of the girl is clear and universally agreed upon. Okay, so however, if I say a set of a beautiful girl in this class, I might say A is the set containing Elsa and Rapunzel. But Olaf might say A is the set containing Anna and Elsa. So, since everyone has different definition of beautiful, the members of the collection vary from person to person. Therefore, this is not a well-defined set. Now let's look more at the other example. So the correct example of the sets is the first, a set of the planets in the solar system. Second, a set of prime number less than 10. And the last is a set of number, then the even numbers between 1 and 10. And the example of not well-defined set is the first, a set of tall buildings. I can say the tall buildings is a 10 meters building, but anyone can say the tall building is the 100 meters building. Then the second is a set of big prime numbers. And the last is a set of numbers close to 100. So this is the example of the set of a well-defined set and not well-defined set. Okay, so set notation. There is three of set notation. The first notation is roster notation. In roster notation, all elements of the set are listed explicitly inside curly brackets separated by comma. For example, A is a set containing 1, 3, 5, 7, and 9. And the second is verbal notation. In verbal notation, the set is described using words by stating the condition or property that the elements must satisfy without listing them explicitly. So, the example is A is the set of odd numbers less than 10. Next. Okay, next, the last is set builder notation. Okay, I'm sorry. Okay, in set builder notation, a variable and a rule are used to describe the elements of the set. It follows from A is the set of all x such as x satisfy the condition of B. For example, A is set of all x such that x is odd number and x is less than 3. I'm sorry, I mean x is less than 10. Okay, next. That's all about sets. So we are going to move to relation. So what is relation? So relation can be defined as a set of ordered pairs that satisfy a relationship between two sets. In other words, a relation shows how elements from one set are connected to the elements of another set. Okay, given two sets A and B. A relation from A to B is correspondence that pairs its element of A with one or more element of B. Okay, the term ordered pairs mean that the order matters. The pair A, B is different from the pair B, A, where is an element of A and B is an element of B. So for example, let's take relation between students and their favorite subjects. So suppose A is a set containing Anna, Elsa, and Rapunzel, and B is a set containing subjects such as math, science, and English. So, so the relation between them is favorite subject. From this diagram, we can tell that Anna's favorite subject is math, and Elsa's favorite subject is English, and Rapunzel's favorite subject is math and science. So, and the same as said, a relation can also be represented in three ways. So suppose there are two sets, which is set A that contains 2, 3, and 5, and set B that contains 10, 12, and 15. And the relation between them is A is a vector of B. So the first way to represent relation is called ordered pairs. In ordered pairs, the relation can be expressed as a set of ordered pairs A, B. So we know that the vector of the 10 is 2 and 5, and the vector of 12 is 2 and 3, and the last, the vector of 15 is 3 and 5. So in ordered pairs, it can be represented as R. Okay, we can see it on the screen. 2, 2 is the vector of 10. 2 is a vector 2 is a vector of 12 and 3 is the vector of 12 and etc. So the second way is within a row diagram. So in arrow diagram, each element of A is connected to its corresponding elements in B by an arrow. So we can see that on the screen that 2 has arrow to 10 and 12, and 3 has arrow to 12 and 15, and 5 has arrow to 10 and 15. Okay, the last is Cartesian diagram. In Cartesian diagram, of elements of A are placed on the horizontal axis and the elements of B on the vertical axis. Each ordered pair A and B is marked as point on the diagram. So we can see this there is 6 points. The first point represents 2 as the vector of 10 and also 2 as a vector of 12. Okay, so there are 3 ways to represent a relation. Okay, let's move to the next material. Okay, so then the last material is about function. So what is function? So function can be defined as a relation between a set of inputs and outputs where each input is mapped to exactly one output. Okay, so in other words, a function so each element of the first set called domain is mapped to exactly one element of the second set called codomain. The elements of the domain are to referred to as inputs, while the elements of the codomain that are actually paired with an input are referred as an output. The collection of all output is called the range. Okay, so you can see that on the screen. The domain is set of all inputs, which is the first set. So there is two set. The set A contain 1, 2, and 3, and set B contain 4, 5, and 6. So the domain of this function is A. It contains 1, 2, and 3. And the codomain is contains B. Okay, I mean the codomain is the B set, which is contain 4, 5, and 6. And the last, the range. The range is a set of outputs that are actually paired with an input. So in this function, the range is 4 and 5. Okay, let's move to the example. Okay, for this example, so which one is function? Okay, can any of you tell me which one is a function? Okay, let's check. Okay, so the function is the one on the left. So we can see that there is two set. Set A contains 1, 2, and 3, and set B contains 2, 4, and 6. And on the left one, their function is fx equals to 2a. So when the input is 1, the output is 2 times 1, is which is equals to 2. And when the input is 2, the output equals to 2 times 2, which is equal to 4. And the last, when the input is 3, the output equals to 2 times 3, which is equal to 6. So every element of the the set E is correspondence to exactly one element of the B. So this is a function. And let's move to the right one. The function at the right one is f(x) equals to x plus 1. So when the input is 1, the output is 1 plus 1, which is equal to 2. And when the input is 2, the output equals to 2 plus 1, which is equal to 3. And the last, when the input is 3, the output equals to 3 plus 1, which is equal to 4. But, but as you can see there, the input 2 is not paired with any element in B. Since 3 is not a member of the B. So similarly, the input 3 maps to 4, which is a member of the B, but the input 2 has no valid pair. So this is where you can see in the function, every input in the domain must be mapped to exactly one output on the codomain. So from my explanation about function, you can see that the key difference between function and a relation is that in function, every input is paired with exactly one output, no more and no less. So that's all our lesson today. We're already learning about set, function, and also relation. Okay, that's all for today. See you and next week. Goodbye.